In this module, we're going to examine the probability of hypertension at baseline in the Framingham cohort as an example probability problem. So in the Framingham data set, there's 4,434 participants. Among those, 3,004 did not have hypertension at baseline. 1,430 did have hypertension at baseline. And we want to calculate the probability that a randomly selected participant in the study had hypertension at baseline. We're going to call this event H. And we can calculate the probability of H as the number of individuals with hypertension divided by the total number of individuals in the population. In this case, it's going to be 1,430 divided by 4,434, which, if you plug that into a calculator, is equal to 0.32. Moving on, we now want to know the probability that this participant did not have hypertension at baseline. We're going to call this event H complement, because it's the complement of the event H. H was defined as an individual having hypertension. H complement is the complement of that event, namely that the individual did not have hypertension. And we learned about complement events this week, that the probability of H complement is equal to 1 minus the probability of H, which is equal to 1 minus 0.32, so we end up with 0.68. And now we want to know, are these events mutually exclusive, exhaustive, neither, or both? So what we know about complementary events is that they encompass all possible events in the population, and additionally they can't happen at the same time. Therefore, they're going to be mutually exclusive and exhausted. So the correct answer to this question would be both. Moving on, we now want to know what is the probability that 3 randomly selected participants all do not have prevalent hypertension at baseline. And we recall that the probability that one randomly selected individual has hypertension is 0.68. Now, given that these 3 individuals are independent, we can say that the probability that all 3 have hypertension is equal to the probability that the first one has hypertension times the probability that the second one has hypertension times the probability that the third has hypertension, or just the probability of H cubed. Plugging that into a calculator, we would do 0.68 cubed and find that the answer to this question would then be 0.31. The last question we want to calculate is we want to know the probability that if we randomly select 2 participants from the population, we want to know the probability that they both have hypertension given that at least one has hypertension. So to start off, let's define the event A as the event that they both have hypertension, and the event B is that at least one has hypertension. And then we want to calculate the probability of A given B. This is a conditional probability event, and we learned that for conditional probabilities, this is going to equal the probability of A and B divided by the probability of B. Now, thinking about the probability of A and B, that's the probability that they both have hypertension and at least one has hypertension. So that actually just reduces to the probability that they both have hypertension, or the probability of A, divided again by the probability of B. Now, to complete this calculation, we need to figure out what's the probability of A and what's the probability of B. So the probability that both individuals have hypertension, since they're randomly selected, it's just going to equal the probability that one has hypertension times the probability that the other has hypertension, using independence again. Now, the probability that at least one has hypertension is a little bit different. Remember, in class this week, we learned about how to calculate events such as this. We wanted the probability that the first participant has hypertension or the second has hypertension. So this is an or type event, and we saw in class this week that that's going to equal the probability that one has hypertension plus the probability that the other has hypertension minus the probability that they both have hypertension. And then you can plug this into a calculator. Plugging in for the probability of H, we know that that's equal to 0.32, and you'll find that the answer to this problem is 0.19.